thank you very much for making the time today to join us at this event at the Shard. So today we're joined by 4 great speakers. First of all, to kick us off, we've got Chris Evans. Chris has worked within the industry for over 28 years now, UK's leading industry blogger, analyst, writer as well. So Chris is here to set the scene, talk to us about where we've come from in today's storage market, and talk about hyperconvergence and the latest technologies and trends. Next up, we've got Andrew Gunyon. Andrew's one of Cisco's City Data Center team. So Andrew has worked with the majority, if not all, of the major firms within the city, helping them in their data center strategy. Andrew's here to talk to us about fast IT and how automation can assist and transform the data center landscape. Next up, we'll have a break for 10 minutes, and then John Arnold from Simplivity will be on. John is Simplivity's Regional Director for UK and Ireland. John is here to talk to us about Simplivity as a business and their hyperconverged infrastructure. Then we'll have Neil Lawton. Neil has led quite an amazing life and is here to talk to us about some of his adventures, which include summiting Everest and flying a car across the Sahara Desert. So I hope that's going to be something different from the techie stuff. If you're able to stay around, it would be great to have a drink with you. So there'll be drinks and canapes afterwards. So yeah, if you can stay, please do. It'd be great to have a chat. So I'll hand over to Chris.
Good afternoon, everybody. Thanks for that, Chris. As Chris mentioned, and I'll stand back, then probably make it a lot easier to read. I've been in the industry about 28 years. I started off in the mainframe, which everybody will look at and think, oh yeah, people always who talk about mainframes always go on and on about how wonderful they were, but they were great at the time. But you know, I've moved on, and I now work more in sort of the open systems environment, a little bit of Windows, but I still look back on that as an interesting time. I actually work for a company called Langton Blue, which I run with a colleague, and we're independent consultants. We work for large banks, large organizations, either giving consultancy or in some cases residency and all those sort of things. At the same time, I do a lot of blogging and a lot of writing. I write a blog called Architecting IT, where I talk about all sorts of things in technology. And if you want to follow me online, you can follow me at the various links you can see there on Twitter or online on the web. So what are we going to talk about today? Well, obviously Chris has already set the scene and said it's about hyperconvergence. So really we're going to look at 3 different things. We're going to look at a very, very brief talk about the technology, and obviously based on time we'll try and keep that as short as possible. One of the things, you know, if there are questions, do shout out, but I'll try and leave some time for that at the end. We'll talk about issues in the modern data center. And then we'll talk about hyperconverged itself and what it really means. Just as a bit of a background, how many people in the room would say they've heard of hyperconverged and have any idea what they think it really means? So there's a good awareness. There's a good awareness of what we think it actually means and what it's about. Good. Okay. So let's talk about the evolution of technology. So looking back quite a few years ago. Thankfully, I wasn't old enough to be working in that sort of environment, but not far off, I have to say. We started off with mainframes that were very, very, very expensive, very monolithic, and you know, we had one piece of hardware, and IBM owned the stack. And that's an interesting message, by the way, when we look as we get further on that into the discussion. IBM owned the stack. IBM owned the rules, the standards, and everything. So that's a really interesting thing to bear in mind. The problem with the mainframe was it was very highly skilled. You needed expensive people to run them, and that's been a problem for the industry going forward. A lot of people just bought bureau services, very much what we might think of as today's cloud. Moving on to the 1990s, 2000s, we changed a lot. We had a lot more departmental machines. We had the start of the internet and the World Wide Web, obviously. You had a lot more smaller devices that were put in departments by people like running operating systems like Solaris, HP UX, AIX, NT, that sort of thing. And of course, we had the emergence of Linux. And within that, in the storage side of the industry, we had the start of storage area networking, which was a real boom because obviously it brought together storage from hundreds of different servers into one place to make it more manageable. But over time, that's become a bit of an issue. And we'll talk about why that's become a bit of an issue as we go further on. Two things at the bottom there that are really important in this. Server proliferation, we saw a lot of proliferation of hardware, and also we saw people starting to build their own fiefdoms, and we had towers of skills being built. And typically, you'd see the server and hypervisor teams, you'd see the storage teams and the networking teams, and although we show them as being interoperable, I think a lot of the time, certainly when I was in this tower, which was the one I was working in, I didn't really talk to the networking guys because nobody really liked the networking guys, and it was anything went wrong, it was always their fault. And most of the storage people didn't really know what the server and the OS guys did. They just sort of gave them the stuff and then let them get on with it. So I know from my experience, the storage side of things, we were quite insular in the way we did things. And we did things the best that we could do, but we didn't necessarily communicate with the remaining towers. And that in itself, as you scale out, has caused a problem. But ultimately, one thing we should be thinking about is all of this is really to deliver value to the business. So we shouldn't be focused on building our own towers. We should be focused on whatever we need to do to build infrastructure that delivers to the business. So what sort of things do we see as problems within that architecture? Well, one of the problems that we definitely have within that architecture is a problem with the buying cycle. So who in this room looks after the storage infrastructure? Is there anybody in this room who does that at all? So how do you do your buying? Do you do it every 3 years? You get a vendor comes in, has got a grade.
Small, to be honest.
Sorry?
It's very small.
Is it? Okay.
Yeah, it's not.
So in the larger environments, what you'll tend to find is the vendor will come in and do you a great deal that will sweep all that other stuff off the floor, and they'll put it down again, and if you don't take that deal up with them, they'll charge you an absolute fortune for years 4 and 5 in terms of maintenance. Because they want you to buy the next thing. They want you to keep swapping that stuff out and keep buying the new stuff. The problem is a lot of the time that means things get based on a project, purchased on a project level. So a project comes along and you buy all of the infrastructure for that project. And at the time that seems like a great idea. But 3 years in, when the maintenance has run out on all of that hardware and somebody else has to pay, the cost of that then becomes a burden to the IT department, and it's very difficult to charge that back to anybody when that sort of scenario happens. We see some of the problems that are in here, like mid-cycle expansions. You see people underestimate and they end up having to go and buy again, and they've already paid for the budget, and then they get into a big discussion about, well, we need more storage than we thought. And even doing that causes problems, because if you put the technology in halfway through, you may find that you have to rebalance everything. You have to spend a lot of money looking at the performance of that equipment just to get it running again. So this sort of buying cycle can really be a problem. So just to emphasize that slightly and a bit more, in the storage world, what we would typically do is we'd deploy some hardware, we'd stick more in. We might have to take a service interruption to put that additional equipment in. When we did it, we'd have to rebalance because that stuff might not actually automatically distribute across the environment. And that becomes a real headache. That becomes real operational cost that you have to put into your day-to-day business. And it's more and more time you're spending keeping the lights on rather than actually delivering to the business itself. Over time, what do you end up with? All sorts of boxes everywhere. You know, one vendor did you a deal one day, so you did it with them. The next day that somebody else did you a different deal, so you got boxes from various different vendors on the floor. And the consolidation cost of taking that out and saying, right, well, now we're going to move it all to one platform becomes incredibly expensive. And the reason I highlight this is because in that deployment cycle, we just spend so much time operationally managing the process of putting in and taking out our infrastructure. So let's quickly talk about virtualization, because as a new technology, this has become quite an interesting angle. I would suspect that pretty much everybody in this room today, if they're deploying technology, by default will choose virtualization as the way to do it. You'll build a virtual machine, you won't build a physical machine unless you absolutely have to. Why did we do it? Because we could consolidate all of these partially running machines that might have been 25% utilized, and we could collapse them down onto a single piece of hardware, and that made our life a lot easier. And on the one hand it did, because it consolidated the hardware, but on the other hand it didn't, because we didn't take away some of the management tasks that we still have to do. So we still have to patch all of those VMs, we still have a lot of work involved with them. So virtualization has given us lots of consolidation benefits. There's still some other things that we have to worry about. However, what we do gain, which is a consequence of virtualizing, are things like high availability. You know, we can cluster these boxes, we can put all sorts of other things in there that allow us to put in high availability without having to pay for that at the application layer, where it would have been much more expensive to deliver. And again, that high availability feature and that idea of scaling out and having resilience between nodes is something that plays out as we talk about hyperconvergence in a few minutes' time. So let's talk about storage and virtualization, because I keep talking about storage because that's my background. But you know, one of the problems that we've always had with storage and virtualization is the two don't really mix particularly well. So examples being, if you've ever heard of the I/O blender as a concept, that's saying that as we put more and more I/O into a virtual environment, we've got less and less idea of the predictability of that I/O. So we create more and more random I/O. And that becomes really difficult for storage devices because they're not really well designed for handling random I/O, and that's a big problem. The workload is unpredictable. We just have no idea which machines will be busy at which times, and it's very difficult to predict what we expect to see. And of course, probably the most obvious one is storage doesn't understand VMs, and VMs don't understand storage. Virtual machines are a package of a representation of a physical server, whereas storage likes to talk about things like LUNs and volumes, and the two don't really sort of fit together very well. There have been some attempts to fix that problem with things like vvols, but I would suspect that there are probably very few people in this room who've really delved into vvols and actually implemented them, and I don't think we've really seen anything of that at all. There are a few vendors who've attacked that separately, and they've come out with VM-aware machines, but you know, it's not the norm in the market to see that. So let's go on and talk about the operational landscape. So we talked about this idea of design, deploy, operate, and decommission. This is the standard cycle we would typically see when we're putting infrastructure in place. So you know, somebody will spend some time designing what they want, researching what they want, deploy it, use it, and then at some stage you take it out. So from a design perspective, what does that mean we're doing? Well, we're doing a lot of vendor research. We have to spend a lot of time going out to the market and looking at what we want from a component level. From a storage perspective, that might mean researching storage vendors, HBAs, fabric switches, networking. From a server perspective, that might be the operating system, the hypervisor, all of those things. And as part of that, we have a team of architects and engineers, really highly skilled people who we pay a lot of money to, who develop blueprints, who put out technical documents, and they have to keep all of those up to date, and they have to make sure that every time something comes out, like a new device or a new set of code or whatever, all of that stuff has to be kept up to date and refreshed. So that's quite an expensive overhead for an environment. If you're big enough to have separate teams to do deployment, you might have people going out into the field, actually taking that stuff and then deploying it for you. In some of the large environments I've worked in, we would have a team that would do nothing but deployment, and that's all they do day in, day out, was put in boxes and configure them. And they would take the blueprints that the architects have given them, and they would use those to do that deployment. And then, again, these are still quite highly skilled people. You're paying a lot of money for them, and they have to have specialist knowledge of the equipment as part of that deployment process. Then we go on to operate. Again, you know, you can imagine what this can be. This is the actual usage of the equipment, so the provisioning, the decommissioning, the actual usage of that technology, the monitoring, and all of those things that go around supporting that technology. Your typical system admin. And there is a good reason why we're talking about all of these roles, as you'll see as we get further along. And finally, decommissioning. Now, this is one I think people don't realize costs them a fortune, don't spend a lot of time on. But actually does cost them a huge amount of money. I was involved in a project last year with a large building society in the UK, and there aren't many left that are building societies still independent. And they did a consolidation of their storage from a large number of boxes to a smaller number. And as part of that, they spent weeks and months, and I would expect millions of pounds, replacing the technology, because they didn't plan properly. There were some gaps in it, and it cost them an awful lot of money and time and outage to the business to do that. So decommissioning, actually, I think, it becomes a real problem for organisations. So really, that just summarises what we were saying there. You're spending a lot of money having people doing all of these different jobs. And we could draw a matrix up that actually shows all of those tasks versus all of the towers you saw earlier in terms of storage, server, and networking. So that means we have a lot of people out there delivering technology. So we'll keep that in mind, and we'll now talk about the software-defined data center. So what does that actually mean? What do we mean by software-defined data center? Obviously, it's a term that I think is probably best attributed to VMware, and why not? Because they're a software company, they want to sell more software, so let's come out with something that talks about everything being software-based. But in reality, we are starting to move towards that. And there are some characteristics of it that I think we need to sort of be aware of, because they are relevant in the way that IT is being started to be delivered. The first one is thinking about IT as a service. So if you imagine the way that you, for instance, when you go and get a mobile phone tariff, you wouldn't have any concern about how that network is delivered to you. All you want is to make sure you can make your phone calls, send your texts, download your data, and you know how much you're going to get charged for all of those things. You want that, you want it to be predictable, and you don't have to want to care about it. If we look at, say, the way that the public cloud is being delivered, public cloud is being delivered as a service, because we don't have to care about how they actually deploy it. We just want to make sure it's there for us when we need it, it's on demand, it's predictable, and it's scalable. And that's the way that really IT in the data center should be delivered, because that is more appropriate to what businesses are going to want. Automation is a big piece of that. There's too much effort being spent on manually doing tasks within the data center that we could automate a lot more. So it makes sense to try and automate as much as possible, take out the people that are in the process, because without that we can't move to delivering an on-demand service. If every time we wanted to provision a server or add more storage and it has to go through a person to do that, that's a delay in that process, and that's just somebody that gets in the way of slowing that agility down. So we don't want to do that, so as much automation as possible. And clearly all of that should be driven by policy. So we should be saying, here's the policy that defines, for instance, how my backups work, or how I deploy my VMs on different types of storage, or how they're protected and so on. Policy rather than hard-coded parameters that define things. As we just said, the public cloud typifies this, very much typifies this. You can just log in, credit card, swipe it, and away you go. Very, 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 very easy. And you don't have to know how that technology is being delivered behind the scenes. That's the whole point, really. The cloud is abstracting that hardware away from you, so you don't have to know that it's commodity hardware underneath. And a lot of the time, if you look at some of the pictures, I don't think I brought one today, but some of the early technology that Google had, for instance, was servers that were PC-based. And there's one example I used in a presentation last month that showed Google just strapped a big battery to every server rather than pay for a UPS, because that was cheaper. And they didn't care if the server died or if it caught fire or whatever. So that was the simplest solution for it. The interesting thing obviously about the cloud is you get economies of scale, and that's something that can be difficult in smaller organizations, but obviously would be great if you could achieve it. The thing is, though, one thing we just need to be very careful of is that software-defined data center doesn't necessarily mean cloud. Software-defined data center and moving to the features of it are an enabler to putting in a cloud, whether that's private or public. This is an interesting slide, I guess, to put up before having somebody from Cisco get up and talk. Bear in mind, Cisco will tell you obviously that the hardware is really expensive and really valuable, and you should be treating it as the Stella Artois of the server market, and expecting it to be reassuringly expensive. But in actual fact, commodity hardware these days isn't junk. Most vendors that are selling servers and I'll let you speak and say your bit, Andrew, on that one. But most of them are selling servers that are coming from the same place. Most of them are being built by the same people. And most of the storage arrays that you're buying are based on servers that are built from exactly the same components. So there's no real difference anymore. We've moved away from that. We've moved away from this idea of having custom ASICs and FGPAs to using standard x86 because it's reliable and it's really powerful. There's just no need to do anything else. And what that means is, of course, a lot of the intelligence is moving up the stack and going into the software. So we're pushing away from having control in microcode and all the hardware and pushing our intelligence and all of the interesting stuff into the software layer. So let's just talk about the business themselves, because in all this conversation we really haven't mentioned them, and I think they're sort of fairly important because that's the whole reason why we'd be here in the first place. So what do the business want these days? Well, as we're moving forward, they want things like flexibility and agility. They don't want to have to sit and wait 6 months for a server to be deployed. They probably don't want to sit and have to wait 24 hours for a VM to be deployed. They just want to get on and do stuff. And as we move into more of a DevOps environment, they want the ability to spin up those VMs on demand themselves without having to go and ask somebody to do it. They want to be able to consume on demand. But obviously, you've still got to do that within budget, and you've still, as everybody gets told year on year, you have to do more with less. Everybody says that budgets don't go up; they're flat, but you're still expected to do more every year. And it's a bit of a cliched term, but it's out there. It's what people have to do. So let's put all that together and see where we've reached. And basically, what we're saying is the traditional IT towers you've seen already, with a software-defined data center approach, don't really fit. The two don't really work together because you've got independent towers working separately, and they don't really give that level of flexibility that the business needs. And that's quite an important piece. One of the other parts of that is, of course, and this is something I experienced, those towers don't really scale very well. We used to have a team in one of the companies I worked in, and we had 85 storage administrators spread around the world. And you wouldn't believe the number of times they overlapped each other, and they'd started doing stuff and conflicted against each other. And the number of times they allocated storage in advance of giving it out to a customer and forgot about it because somebody else got in the way, or they had to wait, or something else like that. And one environment, we went and cleared a petabyte worth of over-allocated storage because of it, just because of the process of trying to deal with that number of people all doing the same job. So the way that we've done things previously just doesn't work, and we need to move on from that. And that's a big change for IT organizations. So how are we going to do it then? Well, the reason we're here today is to talk about hyperconverged infrastructure, and that's one of the things that could be a solution for doing that. So let's look at how we used to do things. So in the old days, we would say we'd have servers, we'd have some sort of networking, and we'd have storage. And this could be IP, this could be fiber channel, whatever. And they'd all be separate, and we'd have to spend a lot of time integrating between the server and the storage. We'd spend a lot of time, and certainly I did, worrying about things like HBA configurations and LUNs and all sorts of things. And this was incredibly difficult to scale when you're talking about petabytes of storage and petabytes and hundreds of thousands of VMs. Very, very difficult to scale and keep in context. So what did we do initially? Well, the vendors came up with this great idea of converged infrastructure. So let's go back to the mainframe. Let's put it all in one package. Let's put it in a single rack, and we'll sell it as a packaged solution that's been built to fit particular requirements. That sounds great. You get a single SKU, so you just buy a single SKU off the shelf. Or at least you think you do. If you've ever looked at an EMC quote for one of these, there are still dozens and dozens of line items you still need to go through. It doesn't actually just give you one line. You still have to look at all the components. And they even charge you for things like the door and all sorts of individual components like that are all line items on that list. But it does help you in some respects because it takes away some of the design work you have to do. The vendor does some of the component checking and validation that these will all these components will work together, because a lot of the components all actually come from that one vendor. There's some of the operate tasks are fixed because they'll automate some of the tasks for you. So, some of the vendors have got some really good automation tools and management tools behind there, which are developing all the time. So, there is definitely some benefits to it. But there's some real problems to it. So, for instance, very few of the vendors will ever talk to you about how you're going to get off this box at the end of it, 3 years' time. And as a result, because most of them can't be expanded, you're not just going to take that apart. Your servers might still be good for another 6 months or 12 months, but your storage might be past its lifetime. Taking it, you're not really going to take it apart, so you're going to get off stuff and not really want to, potentially. And of course, it's all based on one vendor's technology. So let's move on to hyperconverged then. And we've already said that most of the stuff that's out there today, excluding our friends from Cisco who are going to talk about their hardware in a minute, but most of the stuff that's out there today is pretty much the same thing. It's x86 servers, x86-based storage appliances using the same infrastructure. So why not collapse the server, the networking, the storage into one physical unit, one single node, which contains storage, networking, and compute. Add to that to the hypervisor, layer that on, and that's what hyperconverged is. It's basically collapsing the hardware into a single physical footprint and putting the services that we expect into that solution. And what do we mean by that? Well, we take our existing services and we put them onto a box that is effectively running the same code anyway. It's all x86, so why not run the storage components as well as the hypervisor? Nice and simple. What does it do? Well, it potentially makes our hardware utilization more efficient because we're not having to put in separate boxes that might all be underused. It eliminates things like the SAN fabrics. That's a huge saving when you think about the amount of effort that went into managing the SAN, the cost as well as the time and the effort. And we can put in additional functionality because we've got control of the data and we've got control of the VMs and everything in one single uniform package. So now we can add extra features. And I'm sure John will talk about this to a certain degree, but SimpliVity, for instance, will put in data protection. They'll put WAN optimization into their solutions. And all of this is built in for the cost of what you're getting. There are other functions that other vendors are coming up with, but that's a typical example of what's happening. And finally, what do we get at the very bottom there? Well, we get a single point of support. We get one person we can go and talk to. Not only that, we get lots of metrics and telemetry. We get lots of information about the box, all from one single place. And that's really, really powerful, and really, really good. So when we talked earlier about expansion and mid-deployment expansion, one of the benefits of hyperconvergence is we can do that with relative ease. Now, you saw on the previous slide, we talked about the idea that the infrastructure would be built of a number of nodes. Well, rather than scale out by having to buy another storage array, all we have to do now is just put in another node, or another few nodes, however many it is that we need to give increased capacity. So instead of, if you look on this diagram here, instead of having all of this waste at the top of these squares where we've had to put in big increments of technology, now we can put in smaller increments and we can actually not waste as much. So potentially we can be more efficient in the way that we upgrade our technology. We're still using commodity components. We're moving away from needing the SAN. These solutions are a complete infrastructure, so they're giving us all of the components we need. And that's really important. The low cost of entry, the low cost of expansion gives us this ability to scale and deploy without having to think we've got to spend millions on a big storage box and millions on networking and millions on servers. So just as an example, this is how it might work. For instance, you might deploy 3 nodes as an example and have a load of applications running and suddenly find you need to expand it. You put in another 3 nodes and those applications now are distributed across that technology. And the reason that can be done is we have things like a shared distributed storage layer in this solution. So as you add more capacity, you get both storage capacity and you get performance, as well as having more performance to run applications. And that's a really simple solution for people, because you can imagine Whereas previously, if you were expanding the storage and you had to distribute it and relay it out, now you've got a solution where somebody plugs in a node, powers it up, it joins the configuration, and you just start using it. You do it within 5 or 10 minutes. So these are great benefits, and we've talked about some of these already. We've definitely got less plan time because we don't have to go and research everything with all the different vendors. We've definitely got less build time because we just shove in a node, power it up, and away we go. And we certainly have less operating time because one of the benefits of these technologies is you can get a single management console, and they're tightly integrated with the hypervisor. I'm not sure whether, John, you're going to present any slides showing the technology today. No. But if we were going to look at a demonstration, you'd see that a lot of the functions, if you're familiar with, say, vSphere, they're built in to vSphere directly. So you can clone, copy, backup, replicate VMs directly from within vSphere. You don't need any storage guys anymore because the VM administrators can do it all for you. We've talked about the efficiency pieces already, so I don't think we need to go over that one again. But obviously, one thing we did talk about was this whole thing of decommission. You're pretty much taking away the issues around decommissioning. Because if you put a solution like this in 3 years' time, the older nodes are ready to be decommissioned. You put in new nodes, you migrate the workload onto it, you decommission the old ones, you take them away. Very little migration effort involved, and that's a big saving. That's a big saving for teams and big saving for people because you can now run with a tighter team that are more integrated, have got, don't necessarily have to have the full skill set of all of those technologies, can be more generalist, and therefore you can return people to do more strategic projects, which is obviously incredibly important. How can we translate that into something that relates to a TCO? And all I've tried to show here with this diagram is the boxes just represent the cost that it would be to do each of those tasks. And we've just said, let's just assume each of those are equivalent in terms of their cost. Scale goes sort of across from left to right in terms of cost. Well, traditional, we'd have each of those pieces converged. We'd perhaps save time on design and deploy, possibly a little bit on operate, nothing on decommission, and we'd pay a little cost for the privilege of having a consolidated infrastructure. The vendors aren't doing converged infrastructure for free, they're still going to charge you for it. Then we get down to hyperconverged, and you can see there's a lot less design effort, there's very little deploy effort. Operate is going to be fairly similar, but we can still do it within the same infrastructure. Decommission is significantly reduced as well. And obviously, there'll be some cost built into that, but overall, as a TCO, you're saving an awful lot by using a hyperconverged solution over a traditional deployment. I would say, though, that clearly, your savings may vary. It depends on your environment, depends on what you're sensitive to. So you'd have to look at that and decide whether it's right for your environment. So where would you use this sort of technology? Well, clearly, if you're doing technology consolidation, technology consolidation, collapsing virtual or physical server farms, this is a great solution. Really, really easy. You can migrate servers into this environment very easily indeed. It might be that you're doing technology refresh or maybe putting a VDI solution in, or you might be just starting off with a new site. It could be that something like a remote office suits your environment a lot. This might suit a remote office environment for you, where you just need a small amount of servers, a small amount of capacity, but you need to be able to manage that centrally, or you need to be able to manage that easily across a remote network. And hyperconverged is a very good way of doing that because you can do all the management centrally. You don't have to have people on site to be able to manage it for you. So how would you evaluate it yourselves? Well, what I'd say is you'd need to look at your own TCO, be aware of what your sensitivities are in terms of CapEx and OpEx. Where is it you're spending the money? Where do you think you could save? Storage might be a big problem, and that might be something you want to attack with that. But also, you might have other opportunities you could put in there. You might be needing to replace a backup solution, and a hyperconverged solution might do it for you by bringing it all together. Talk to the vendors, clearly. Vendors are in the room today. I'm sure they'll have plenty to say, and they'll be very happy to talk to you about your technology. or you could talk to consultants and experts, which I guess is why I'm here today. Or of course you could use social media and get the wisdom of the crowd and just go looking at things like Twitter, and you'll find lots of conversation about this technology. That's well worth looking at that. And with that, I think we're pretty much on time. And I'll open it for questions if anybody has any. That was very quick, I have to say, but we're trying to condense into a small space of time. So, anybody got any questions on that? Great, not one question. Oh, no, go on then.
I've got one. You've got a use cases slide
Yeah.
for hyperconverged. Are you saying that they are the only ones?
No, not at all. So I'm giving you some examples to try and make you think, where would in my environment could it be useful?
Where wouldn't you? What applications would you not put on hyperconverged
Well,
infrastructure?
Some of the very, very big in-memory applications probably wouldn't be suitable. I think we haven't quite got to a position where some of the SAP HANA type applications are being recommended for that sort of thing. I wouldn't say, anything that's sort of high, really, really high compute or storage requirement, like an HPC type solution, probably isn't suitable for this. But if you're big enough to have those sort of solutions in the first place, you're probably big enough to already have something dealing with that anyway. Those are the sort of things I think you probably wouldn't put it on.
The way you explained the architecture, you showed that just simple building blocks, expanding compute and storage nodes. What happens when you don't want to scale them linearly?
Okay. Different vendors have different ways of doing it. So different vendors have different node types. So you can buy heavy compute nodes, you can buy heavy storage nodes. Some will even do storage-only nodes now, which sort of breaks the rules really, because that's sort of that goes back to having a SAN again. But you can mix and match in that. So some vendors will do like an all-flash node, or they'll do something that's just got disk in. So really what you can do is you can look at it and say, well, where am I heavy or light? And then where do I need to buy next? And because these solutions distribute the workload across the nodes, both at the storage and the application layer, you can make best uses of the resources. Now, what you will see is within that, they'll have schedulers that will allow you to say, well, that should sit on there because that one's going to get the best use of the performance of the storage, or vice versa. And a lot of that is taken care of behind the scenes. Great. Well, thank you very much for your time. And I'll be around at the end. And shall I hand back over to you, Chris, or shall I hand straight over to Andrew? There you go. Thank you.
So thank you for that. A couple of changes on the slide set. No, thank you for your time. So I want to talk about fast IT, because actually one of the things and the challenges that most businesses are having is how many of you know how much AWS or public cloud consumption is happening in your business? Do you have a good understanding of what that's happening? I would suggest a lot of you don't know that it's actually happening in your business, and you don't know how much it's costing you. And a lot of that is due to the fact that you get demands on you to deliver new services that you struggle with because of the way that the systems have been built in the past. So I wonder if how many of you, that's the sort of scenario you get on a Monday morning when some developer says, I need to do something, and you get to that conversation and you go, well, yeah, the window's open in 3 months' time. We see this quite a lot. And the reason is because of the way that the systems are built and the inflexibility that it doesn't give you today. And that's because IT hasn't evolved to be able to be the broker of services. So what we are seeing is the line of businesses with inside organizations is saying, if you can't do it for me, IT, I'll go somewhere else and do it myself. So we're seeing a lot of pressure internally. And poor old Rob, this is one of our engineers, is a graphics designer, and he always takes the mick out of everybody, and that's yeah, Rob's not here, so you can't tell, but that's Rob. And what typically is happening is, and we've mentioned this before, so some of these slides will duplicate. There's an awful lot of siloed type environments with inside businesses, whether it be storage, networking, computing. Then you've got the whole plethora of vendors that you're doing around security. And that's really starting to slow things down because you end up with compliance getting in the way. And it basically means it's a manual process. There's an awful lot of customers that still have configurations held on spreadsheets. It's amazing how many times we see that, and it makes it very difficult to move quickly. The other thing is you have inconsistency, so you have human error kick in, and that makes a huge difference. If you look at no one's from the banking industry here, are there? So can't get into your bank account because someone's hit the wrong button on the code. So what it's doing is, IT is slowing everything down, so it's making the business not be able to react fast enough. And that's really, really critical. How many of you use Airbnb? Yeah? Uber? Yeah. So you're now competing, or you're buying your hotel rooms by clicking a button, and you can choose from 800,000 rooms, and it took them 14 months to do that. It took Hilton 40 years. So they're now competing against somebody who's born on the web, doesn't have to worry about building something in an IT shop because he goes out and buys stuff. Uber's brilliant. It's Google Maps. It's an application that they bought for you as a user. The taxi driver has one, and a billing engine. That's it. They didn't go and create anything in an environment with hundreds of developers. They just pinched it off the web and packaged it fantastically well. That's what we're up against, and that's the competition. So shadow IT is becoming more and more prevalent, but it's also very expensive. Building a private cloud should save you, if you put it into another environment, it would be twice as expensive to put it into a public cloud and leave it there for a number of years. Because guess what? You forget, you move on, the phone rings, and you just leave that service going, and your credit card bill just keeps picking up. We've seen customers get really shocked when we run a sniffer on our access points and find out how many people are actually logging into these services and going around IT. It also has a big issue around security, and data sovereignty is a really key thing today. So what's happening is IT is being marginalised. The budgets are now slipping more to the users and the business people inside the organisation because they're not prepared to wait. They've got an application they want to deploy that can either generate more money, improve customer satisfaction, and they're not prepared to wait for IT who can't deliver on these promises. So what Cisco's been doing for quite some time is we work with a number of people. So there was another analogy earlier on. We're the Swiss. Cisco's the Swiss of the storage world. And we work with a number of different partners to provide converged and hyper-converged solutions. We build validated designs so that you don't have to take the risk of trying to plumb this stuff together. And we'll do single number support to allow you to be able to take that and know that it's going to work, and we'll back it up. And everyone knows Cisco support is pretty good. So what is hyperconverged? It's the same sort of slide set. We did talk to each other before we came on, but as you can tell, the trend is very similar. A converged stack is what it is. It's got discrete components. And what we're starting to do more and more is to start looking at how we can build scalable solutions. But we want to talk about an architecture. It's really important that you don't start buying bits of individual technology to do a specific thing and then find out that one won't talk to each other, or you can't move workloads from one format to another. Really, really important. Cisco's data center products is a software-defined computing. If we'd called it that at day one, 7 years ago when we started to build it, everyone would have understood what we were doing. At the end of a network, there is a resource, and we can control it from a single place. Storage, networking, hyperconverged, compute, all done from the same place. We're fairly unique in that, and that's allowed us to get to the number one position in blades, for example, in the US, number 2 here, by offering a better solution where we tear out a lot of the costs. So one of the comments you made was, we like to sell you ASICs and cards and stuff like that. We've taken all of that out. We've removed it. It doesn't exist in our platform because we've virtualized the hardware layer. We've done this for quite some time. So hyperconverged allows us to really move into a very quick and easy way for you to deploy a service in minutes, not in days or months or years. With the way that we've designed and built this and the way that we control it through software allows us to provide a portal for you to your users where they can click on a service and it will automatically deploy it. Your technical guys don't need to know how the SAN works, the LAN works, or the storage layer, or the hyperconverged. They can click and deliver a service from a single pane of glass. And it's that whole automation and an infrastructure. So if you want a highly dense environment, you can have it. If you want a blade environment with a converged stack for specific applications, you can have it. But it's all controlled from the same place. And that's what's made Cisco be fairly unique. And you've all got the same objectives. You want to do more with it. You want to pay less for it. That's always a question. We never get a budget saying, I've got a bigger budget, what can we buy? But you want to take the risk out of it. You know, no one wants to have something that's got a manual intervention that means that something could go wrong and cause you to lose data, have a breach from a security point of view, and you want to reduce the complexity, which is why Cisco works with a number of partners to help drive that. So we talk about fast IT. It's about programmable infrastructure. We are not interested in point product. Cisco's done something very unique in the data center. We have open APIs, and that allows us to have our competitors plug their services into our model as well, but allows us to build a solution for you and your businesses. We automate and orchestrate it. We do not want to have to touch something to build something. We've got to take that person out. If we don't, we can't move at the speed that the web can do that. The other thing we have to do is we have to try and make it easier for you guys to be able to deploy an application across a network without you having to worry about whether or not you've configured every single switch. Who said a Target? It's a US company. It's like a Woolworths. So they got a breach quite a while ago, actually, and they lost about 2 million records, customer records. The frightening thing was that they actually lost $2 billion off their market capitalization overnight because of that perceived security list. And they got in through the air conditioner controller that was connected to the network because they didn't check that one piece, or they didn't make sure the security policy was applied to that. Because quite rightly, the IT guys go, it's not in the data center, it's sat outside behind the shop. So we have to start looking at how you can automate the provisioning of services that allow you to be able to deploy things in a safe and timely way. And that's very, very important. There are still physical workloads that people need to do, and we can do either. It's not an and or, it's not an either or, it's an and. And the last thing is, if you've got all this data and you're trying to do something with it, you need to be able to crunch it in a way that makes it valuable. Who's got Tesco's Club Card? Right, so we all go shopping on a Friday, you come back home, you bought all your shopping, and on Saturday morning out comes a bit of paper with a voucher for something you bought yesterday. Well, that's not much use. You want it there. It's got to be valuable. It's got to be timely. If it's not timely, what the hell are you doing with it? Just stop doing it. So a lot of partners and customers have got traditional IT shops, and then they've got the web-based applications. And what we're seeing, and what Gartner are calling it bimodal, is that customers now don't change that part because you can't, but start working in a two-mode process where you're born on the web, fast IT, DevOps type environment where they need to be able to click and scale very fast. And that's where the hyperconverged really works, because you can scale it up by both storage nodes and compute nodes. And traditional converged environment sits in here. And what that really means is you're going away from a different mode where this was all risk averse. Standard mode 1 was all about risk aversion. Don't take a risk. Cool, it might be dangerous, data might go somewhere else. You know, can't afford to have an outage, so over provision to a massive amount. To a hyper-converged things where you've got to do it yesterday. If you can't do it, in a day, don't bother. Cisco does this quite a lot now. So if you want to take time off in Cisco, don't go looking on the web in our internal systems, you'll never find it. But they'll give you an app on your phone and you'll just click on it. And they're chopping up these services into microservices that they can constantly change. If they make a change, it doesn't work, they don't care, because tomorrow they'll do another version and it'll work. So it's this whole speed, single UI, very, very simple, chop everything up into a logical thing. So it's about an architecture. If there's one thing I hope you get over today is think about what you're trying to do and take a bigger picture of what type of technology you need to deploy for your business, but make sure that you can do it in such a way that you can manage and control it in a very simple way. Single pane of glass, scalable to massive numbers of servers, 160 servers per domain. You know, the ability to do it over multiple different sites from a single site. and then look at how you would then start to offer those services back as a portal for your users so that you don't have to touch it. You're providing those services that they're currently looking at other places to go to. And we can do it across all the different platforms that Cisco has in its DC portfolio. So what we want to do, what we are delivering to our customers, is IT is now the broker of a service, whether it's on-prem, off-prem, private or public, but it has all of the controls and rigor around it that you expect when you run your business. And finally, what we are delivering to our customers today is the ability, using our software layers, to merge all the different provisioning tools into a single place so that the customer, you guys, can actually start to relax about provisioning and concentrate more on how you can add value into your businesses. And that means Rob relaxes a little bit because he's in control of what he's trying to do. Are there any questions? Can't believe it. Must be coffee time. Thank you very much.